Welcome. Hi, I'm Mikki, and this is Mikkipedia, where I sit down and chat to doctors, professors, athletes, practitioners, and experts in their fields related to health, nutrition, fitness, and well-being. And I'm delighted that you're here. Morning, everyone. This is Mikki here, and you are listening to Mikkipedia. And this week on the podcast, I speak to Dr. Stephan Guyenet. He is an obesity researcher, neuroscience expert, and author of The Hungry Brain. And we talk all about energy balance, weight maintenance, and the role that the brain has on these things. And Stephan's such an expert, but he's also so good at science communication. It's something that he really does a lot of work in. And so therefore his explanations around these things are just so understandable for the general audience, which is great. Otherwise, I would have no idea what he is talking about. So we discuss the role of hormones, the food environment, the brain, and how to manage to maintain a healthy weight when these things tend to conspire against us. For those of you unfamiliar with Stephan, I came across him a number of years ago at the Ancestral Health Society conference I was in 2014, and he has a Bachelor of Science in Biochemistry and a PhD in Neuroscience. And then he went on to study the neuroscience of obesity and eating behaviour as a postdoctoral fellow. He has spent 12 years in neuroscience research world studying neurodegenerative disease and the neuroscience of body fatness. His publications in scientific journals have been cited more than 3,600 times, and today he continues his mission to advance science and public health as a researcher, science consultant, and science communicator. His book, The Hungry Brain, which I highly recommend, was released back in February 2017, and we talk about what he might update if he was to rewrite a version of The Hungry Brain today, as obviously the science has moved on. So we talk a little bit about that as well. Now, it was named one of the best books of the year by Publishers Weekly and called Essential by the New York Times Book Review. He is a senior researcher at GiveWell and scientific reviewer for Examine.com, which is an amazing independent research digest. I highly recommend that too. And he's also the founder and director of Red Pen Reviews, which publishes the most informative, consistent, and unbiased popular health and nutrition book reviews available. And my colleagues and I really appreciate the work that Stephan puts into these sort of independent reviews, as it really makes it so much easier to sort worthwhile information compared to, say, information that isn't science-backed or doesn't have that body of evidence behind it. And so that's what Stephan spends a lot of his time doing. And he also periodically contributes to the scientific literature and is a review editor at the Frontiers in Nutrition. You can find Stephan over at his website, and I'll put a link down in the show notes too there, or over on Twitter, where he shares a ton of sort of up-to-date information on a daily basis. Just before we kick into the podcast, peeps, I'd just like to remind you the best way to support the podcast is to hit subscribe on your favourite podcast platform and head over to enter a 5-star review for us so people become more aware of Mikkipedia and the information that I share on this platform. If you want to go one step further, you can absolutely sign up for the recipe portal access over on Williden.com. $12 a month, you get regularly updated recipe index of over 900 recipes now. You get access to our members only Facebook page where I run a forum weekly, irregular Facebook lives, and also access to my weekly email. All right, team, I hope you enjoyed the conversation that I had with Stephan Guyenet. Stephan Guyenet. I've said that right, haven't I?
Yep.
Lovely. Thank you so much for taking the time to chat to me today. I've been following your work for forever. You're such a wonderful science communicator, and you do such a great job of putting those really complex topics in and around obesity, the brain, distilling information sort of for the general population for many years. So it's a privilege to be able to chat to you.
Thank you. Glad to be here.
Stephan, obviously you've got your book, The Hungry Brain, which I believe was published maybe 5 or 6 years ago now. And then also your website, the Red Pen Reviews, which sort of gives us a snapshot of popular diet books and how they rate with regards to their accuracy or credibility and essentially, how useful they might be for people. So, science communication is something which you obviously enjoy, but of course you have a neuroscience background. So how have the two sort of come together for you to be doing what you do now? Let's start there.
Yeah, so I've always been interested in neuroscience. It's just a really interesting, complex topic that relates to who we are and pretty much everything about how we live our lives. And always been interested in health and nutrition, how we can, live our best lives throughout our lifespan. And the neuroscience of obesity is where those two things converged. And so I did some research on that as a postdoc at the University of Washington, trying to understand the biological changes that occur in the brain that maintain and perhaps create the state of obesity. And then I followed that up with a general audience book that you mentioned, The Hungry Brain, which was my attempt to take all of this science that was uncovering all these really fascinating, informative things that wasn't really getting to the public. It was my attempt to get some of that information out to the public.
And I've heard you sort of speak on the topic on a number of podcasts that, it was surprising to you that there was this literature in and around the brain and obesity, yet these weren't the things that people were thinking about. They were thinking about whether carbs were the best thing to restrict or fat was the best thing to restrict. Has that changed at all over the last few years as your book has come out and other sort of publications have come out, do you think?
I think it has started to change, actually. I think, I don't know that this is something that has really percolated all the way down to like broadly to the public, but I think among people who are most engaged on this issue, I think there has actually been a softening over time of this very tight focus on macronutrients. So primarily fat and carbohydrate is what I'm talking about. I think if you go back even 5 years, there are like these really hard camps of low carb is the way and fat and carbohydrate is fattening. And then there's kind of like more low fat plant-based camp that thinks that's the way and dietary fat is fattening. And I think, I don't know, maybe I'm biased, but my perception is that everyone is kind of softening up a little bit and saying, kind of acknowledging that the evidence isn't quite there to support such a hard stance and that maybe it's a little bit more complex than they originally thought, and there are other factors that matter. I see a lot of people who used to be like really hard line about calories being completely irrelevant now coming around to, okay, actually they do matter. Let's have a more nuanced conversation where we're, acknowledging evidence from multiple areas about multiple factors influencing this system. So I think there has been in recent years a softening, which is kind of nice to see.
For sure. And I often see your name in relation to the carb insulin model or the energy balance model with regards to gaining or losing weight, if you like. And to me, and hopefully we'll go into both of these theories further along, but they're both two different theories, yet I've always sort of just thought, could possibly elements of both of them be correct? Like, does it have to be one or the other? Does everything have to be sort of mutually exclusive? Yeah, I find that super interesting.
Yeah, I mean, I think there are really two ways you can look at this. The first is the purely theoretical way. You can say, are these theories, in theory, are these two ideas mutually exclusive? So, you know what? Let me take a little step back and just make sure everybody's coming along on what we're talking about here. So, carbohydrate insulin model is the idea that carbohydrate is the primary cause of obesity via effects on insulin signaling that cause fat tissue to kind of suck up fat and not release it and kind of starve your other tissues of energy, which makes you hungry and makes you eat more. That's kind of the basic idea of the carbohydrate insulin model. Energy balance model is saying the brain is in charge of calorie intake, of calorie expenditure, and fat tissue, for the most part, is just kind of, it's a storage organ. So if you're consuming, it does play a role in regulation via the hormone leptin, but if you're in positive energy balance, your fat mass increases. If you're in negative energy balance, your fat mass decreases. So the changes in your body fatness in that model are downstream of the changes in energy balance, energy intake, and expenditure, whereas in the carbohydrate insulin model, it's reversed. Changes in energy balance are actually downstream of your body fat, the process of your body fat increasing. So that's kind of the two summary of the two ideas, just to make sure everybody's following what we're talking about. And yeah, so in theory, they're not mutually exclusive. In theory, there's nothing that says that they couldn't both be true. So that's the first way to look at it. The second way to look at it, though, is to say, what is the evidence that supports each of these models? Yeah. Because even if in theory they're not mutually exclusive, that doesn't mean that they're both correct.
Yeah.
And so the second way of looking at it, I think there's a lot, the evidence supporting the energy balance model is a lot stronger than the evidence supporting the carbohydrate insulin model, at least as it pertains to everyday common obesity. So the average person with obesity walking down the street, I don't think the carbohydrate insulin model explains how they got there.
Yeah.
Because if you just look at it at a very basic level, physiologically, the person with obesity, they have higher total energy expenditure. So they're burning more calories per day than a lean person. They have higher lean mass, more muscle, more organ mass. So not just more fat, they have higher lean mass too. They have higher or equal or higher levels of blood sugars versus a lean person, equal or higher levels of circulating fats. So if you look at everything physiologically in a person with obesity, it's not an internal starvation. There's not a lack of internal energy happening. It's not like fat tissue is sucking all the energy out of the rest of the body. Everything's firing on all cylinders. It's a situation of internal excess, not internal starvation. Yeah. And so I think the big picture is, I think the energy balance model is a better description from just the basics of what we see of obesity. But that doesn't mean, again, since they're not mutually exclusive, if in the end it turned out that, like, let's say 90% of differences in body fatness were explained by the energy balance model, 10% were explained by the carbohydrate insulin model, that wouldn't surprise me that much, because when you get into smaller effects, they're harder to observe, harder to measure. So it could be flying under the radar. I'm not going to say that it's not. I just don't think we have clear evidence that it is at this point. But I think there are some cases where you might, if this is happening, you might expect to see it in certain places. So, for example, there's a condition called sarcopenic obesity, where people have very low muscle mass in conjunction with high fat mass. That's not a description of the typical person with obesity, but there is a certain subset of people with obesity that are like that. And if you were to say to me, in 10 years, we're going to figure out that that's mostly caused by the carbohydrate insulin type thing, that would not surprise me that much. So again, there could be a part of the explanation. It could even be the main thing in some people, but I think it's not a good fit at all for your kind of like typical average person with obesity. I don't think it's a good explanation for the typical scenario of obesity.
Yeah, no, that makes perfect sense. And I want to come back obviously to the premise behind your book and the mismatch that you describe in between, what's going on in our brain versus what's sort of happening out in the environment. But one thing I know, Stephan, from following you is your interest in genetics and the genome and how that might play a role in obesity and overweight. And as I understand it, it might play a minor role if we look at it from a sort of population perspective, which is sort of what you've just described with regards to the carb insulin model. But how important is the genetic element with regards to obesity as you see it?
It's immensely important. And some of the, I want to say big picture that some of the greatest advances that we've had in this field recently have come from genetics. And that's one of the reasons why I've been so interested in it. I mean, if we zoom out all the way and we just say, how much does genetics matter in general in humans in explaining differences between individuals? So if you look at two people, they look different in many ways, right? They have different personalities, they have different facial features, different skin color, different disease risk, et cetera, et cetera. And you can measure the genetic contribution to all of those things and estimate how genetic is it. And it turns out most things are pretty genetic. Not to say they're entirely genetic, but for most traits, there is a quite substantial genetic contribution. Typical would be anywhere between 25 and 80% of differences between individuals, maybe 20 and 80%. So for most things, there's a lot of genetics in there, even personality things that really we understand are primarily related to the brain and that relate to, very intimate details of who we are. Those things also are strongly influenced by genetics. And so I think it should come as no surprise that about 75% of differences in body fatness between individuals are explained by their genes. So it's extremely influential, genetics on body fatness. And if we look at what those genes are doing, so what I just told you is from a type of study called twin studies, and that tells you how much of the differences between individuals are explained by genetics, but it doesn't tell you what the genes are. Yeah. And to know what the genes are, we have to go to different methods, particularly genome-wide association studies, that they're not as good at telling us what the total genetic contribution is, but they're better at picking out individual specific genetic differences that are contributing. And if you look at those, what we see is that the genetics of it are heavily, heavily enriched for brain-related genetics. So basically, if you ask the question, if you look at the data and you look at all the genes, or the locations in the genome that are implicated, and you say, what organ are these primarily acting through? You see that overwhelmingly it's the brain. So, if you were to look at height, differences in height between people, you would see that it relates to things like growth of bone and connective tissue, growth hormones and stuff. But if you look at obesity, it's primarily about the brain. Yeah. And so that dovetails well with other evidence we have that differences in body fatness between individuals are primarily the result of genetic differences in how different people's brains are constructed. Yeah. So that's the primary determinant of why some people are fatter and some people are not in an affluent country like the United States or Australia. Yeah. And I want to expand on that a little bit, because I think a lot of people hear that and they think that I'm saying that genes are the only thing that matter, or that the environment you live in doesn't matter and diet and lifestyle doesn't matter. That's not what I'm saying. And, typically people will say, well, 50 years ago, there was a lot less obesity and we had the same genes. So how could it be the genes? Yeah. So I want to anticipate that. The reason is that the way these studies work is the studies that I just described, they're not looking at the difference between today and 50 years ago. They're looking at the difference between a bunch of people that are alive today in the current environment. So what they're saying is they're explaining differences in body fatness between individuals right now, what explains those differences. And that is primarily genetic. But if you take this whole population right now, that in the United States, for example, 43% of US adults have obesity. If you take this whole population and you put them back in the hunter-gatherer days with, sticks and loincloths, then you're not going to have the same rate of obesity, right? Yeah. So you'll still have differences in genetic susceptibility to obesity. So if you were to then, after that, take those people and put them back into a fattening environment, the same differences between people would emerge again. So there's a susceptibility there based on the genes, but if it's not in a fattening environment, it's not going to express itself.
Yeah.
Does that make sense?
Yeah, it makes total sense. And so I'm a twin, and we're fraternal, so different. And we are actually quite different the environments we live in are different, but our body shape and our propensity to gain weight, our body shapes as they are now are very different. And I've always thought it's just been something about the way my brain is wired that has meant that I'm super into healthy food and really enjoy physical activity, whereas my sister doesn't necessarily enjoy either of those things. So for her to sort of put into place behaviors that I naturally do, like, it's actually quite a struggle for her.
Yeah, this is a really interesting topic to me because I feel like people who are lean, they often like to attribute that to their behaviors and their, motivation and their willpower or whatever, good choices. And some of that's true. Obviously diet and lifestyle impacts body fatness, but why did you make those choices? Why do you have health? Why do you like to exercise? Why do you like to eat well? Well, that's probably partly genetic.
Yep.
So, I mean, any way you slice it, there's a genetic contribution there. So, and then of course there are other things that we would recognize as less under our voluntary control, like just our raw appetite. Some people just have more appetite, and it's not, even if you gave them the exact same food, they would eat more just because that's how they're wired. So yeah, I think, people like to assign themselves virtue, when in reality, a lot of it's just the way the dice landed, the way the genetic dice landed. But I also thought, I thought it would be maybe interesting for you to hear about how these genetic studies are conducted a little bit more, because it actually involves twins.
Yeah.
Some of them involve twins, some of the best ones. And the way they do it is they compare how similar are fraternal twins versus identical twins.
Yeah.
And so the idea is these, fraternal twins both grew up in the same uterus, were raised in the same household, and the same is true of identical twins. So the environment they're exposed to is pretty much identical. However, the difference is that fraternal twins share half of their genes, whereas identical twins share all of their genes. Yeah. And so you can look at how much they differ from one another on whatever trait you're trying to measure, and that will tell you how genetic it is. And so what you'll find if you look at fraternal twins is that they are more similar than just two randomly chosen people in terms of their body fatness, because they're half related, but they can still be quite different in their body fatness. Yeah. But if you look at identical twins, they're very similar in their body fatness. And if you do things like overfeeding in experimental settings, this has been done, they gain the same amount of fat in the same places on their bodies. It's really quite striking. And so by noticing that identical twins have body shapes that are much more similar than fraternal twins, you can actually put that through a mathematical formula, and that will tell you how genetic it is. It will give you an estimate of the percentage of the differences between individuals that is accounted for by genes.
Isn't it so interesting, isn't it? And I've often also thought, like, people, so again, as a nutritionist, healthy eating it's not even a thing. Like, I just eat, if that makes sense, and the things that I tend to like are things which are sort of healthy. And I've joked with people is that it comes so easy to people like nutritionists. It's because we're just different. We're just wired differently on the food front. It's potentially hard for some people to understand how you can't eat healthy or how you live on junk food when it would never, there's a certain obsession, if you like, with regards to food in order to be a nutritionist. So I've often thought, oh yeah, just genetically wired to enjoy being that way.
For sure. As I said, I think a lot of our personality traits are strongly impacted by genetics. And, I'm like that too. And it's like hard for me to understand sometimes why the public eats the way they do. When I look at data on what the average person eats in the US, I'm like, this is atrocious. It's absolutely atrocious. And I'm like, how could you do that to yourself? But it's not me, it's a different person living a different life with a different brain.
Yeah.
And everybody's just, put together differently.
Completely. And Stephan, before we move on to exactly that topic of the environment, sort of the food environment and what part that plays, there are these sort of consumer-based reports now looking at genetics, looking at particular genes and how they might relate to certain, phenotypes or cholesterol metabolism and that kind of thing. The genes that you're talking about that impact in our brain on obesity or propensity to gain weight, is that at a point now where we could potentially find that information out, or is it only in that research setting? Would it even be helpful for us to know that we have this genetic, trait?
That's a good question. So I tend to be pretty skeptical of the value of that information to the public right now. So essentially the latest of these genetic studies that I've seen where they're identifying specific locations in the genome is able to explain, I think, like 6% of differences in body fat between individuals, or differences in body fatness between individuals. So we're not to the point where we've identified most of the genes. We're really just kind of dipping our toes into the water in terms of the bulk of it. So would it be useful? I think probably it's not going to add a lot of information to what you already know about yourself, especially if you're an adult. I mean, you know how susceptible you are to fat gain by the time you're an adult. You probably have a pretty good idea. So it's hard for me to imagine what it would add on top of what is already obvious to you in your life. There are a couple of exceptions. So for people who have severe obesity, especially severe childhood onset obesity, there are some genes that can be tested for that are not that uncommon in severe obesity. Something like maybe 5% of kids with severe obesity have these single gene mutations, for example, in the melanocortin-4 receptor, which is involved in body fat regulation and appetite in the brain. Kids who have these mutations, and by the way, some dogs have this too. Kids who have this mutation just are insatiable and really put on a lot of fat to a very concerning degree. And so, I don't know what's currently being done clinically about this. I'm not a doctor, so I have limited insight into that side of it. However, there are tests for this genetically, and I think now they're coming out with treatments for it as well. That's part of the question is this even actionable? Is there anything that can be done with this information? And I think now we're getting to the point where a certain percentage of people could potentially act on some of that information. I suspect for the average person, it's not going to be very informative right now. But I think absolutely we will get to the point where it will be useful, because this genetic research is progressing so quickly that 6% I told you about, the 6% of differences in body fatness that's been explained thus far, that's going to be 10% in a few years, and then it's going to be 20%. and then it's going to be 40%, and then maybe higher.
Right.
And once you get that kind of information, you could genotype someone at birth and say, this is a child that's highly susceptible to obesity. Let's make a plan right now to prevent that from happening.
Totally. And as soon as you said that, I thought of all the people that would be out there going, oh my God, you can't do that to a child right from the word go, only because of the, potential restrictions and regulations or restrictions that they might.
Well, I think you'd have to do it with the parents' consent, of course. I'm not talking about the government doing this.
No.
But I mean, I think with parental consent, it would be a great idea because, I mean, think about the alternative is we just ignore it and the child develops obesity and significantly impaired in terms of their health and their movements, potentially for the rest of their life. So I think there's a very strong case to be made. And also, treatments for obesity are getting a lot better now too.
Yeah. Yeah.
And so, we're getting to the point where not only can we predict, but we actually have much more power to do something about it. Yeah. So I think it's all potentially going to, come together it could potentially come together into a much better situation for obesity prevention and management in the future.
Yeah. That would be amazing.
And it's coming fast.
So I did my master's in childhood obesity, and we essentially went into a small community, put in water fountains and made fruit more available. And that was the extent of the ability to change the environment. And I wonder if you get a bit frustrated if you look at the obesity literature, as you've studied as well, and everything seems so ineffectual, and from a population perspective, you always hear that, if you shift the population obesity rate by 2 or 3%, that's, highly significant. But then down at that sort of individual level, nothing seems to stick. And I think that in the Hungry Brain and the idea of your work in that space of how there's this mismatch between the environment and how we live in it, or what we should be living in, definitely sort of addresses why the treatments thus far have been pretty dismal.
Yeah, I totally agree with that. And I think that you're absolutely correct that the kinds of public health approaches that have been tested so far on a small scale have largely not been very effective. And I think you're right about that. I think it is sad, but I think it reflects the nature of the problem, which is really quite difficult. So if you look at the average calorie intake in the United States, calorie intake in US adults since before the obesity epidemic, it's gone up now by something like 250 calories a day. And so that is the amount that it needs to come back down on a population level to get rid of this. And it's actually even more challenging than it appears because not everyone is fatter today than they were before the obesity epidemic. It's only a subset of people, the ones that are susceptible, that are developing obesity. And that subset it's a lot of people. It's, maybe half of people, but it's not everybody. And so how much has those people's calories gone up relative to where they would have been in the 70s? Probably by more than that, probably by something like 400 calories a day. And so you're having to target on a population level, a public health level, a reduction in calorie intake by something like 15 or 20%. And that is, that's massive. That is a massive task. And so if you're talking about individual levels, individual effects in highly motivated individuals, you can get those kinds of reductions. If you're working with a dietitian, you can get reductions like that. But if you're just talking about public health, like what can we tweak in the environment to cause people to passively eat that much less, that's a really tall order.
Yeah.
And so I think that's kind of the problem we're facing. And I don't think, so I think that's the problem we're facing. And I think that the things that we've done so far are just not anywhere near up to the task of doing that. And I think, I can't speak for Australia, but in the United States, we've really done very little to combat obesity. Really very little. And I think the reason, not nothing, there's some things that have been done, but it's been very minor. And I think the reason is that there's not an appetite in the public or in the government for regulatory change. Like, nobody wants the government to tell them what to eat. People don't want the government to tell them how to raise their kids.
Yeah.
People don't even really want government regulating corporations very much and what the corporations can do. And there's only a few exceptions to that are palatable enough. Like, for example, I think people are mostly okay with the government, or actually, I think people are like comfortable with the idea of regulating like food advertising to kids of junk food. Although right now, I think the regulation is voluntary in the industry.
Yeah.
And in the US, and people are okay with like sugar sweetened beverage taxes, soda taxes, as long as they're small. But even that gets a lot of pushback.
Yeah.
People are like, you're hurting poor people.
Yeah.
Because poor people drink. I'm like, what hurts poor people is diabetes. And that's like about the most that we've done here. So I think that there's very little tolerance in the American public of the government interfering in what they eat and how they raise their kids. So it's hard for me to see this really changing enough from a public health perspective, like the government doing something or nonprofits doing something sufficiently to reverse the obesity epidemic. Doesn't mean we can't do anything. Doesn't mean we shouldn't try. Maybe we could move it a little bit, but it's hard for me to see that kind of public health regulation doing enough to reverse course on a population level, given the massive changes that we've seen in the way that we interact with food over time. Rolling that back is just not realistic.
Completely appreciate and agree with that. And you mentioned, we were chatting before about how it might be difficult to understand how someone can eat a certain way that, that doesn't seem to make sense. And I think about that, and I think about ultra processed food and the number of calories that people can get from different food choices, which are the cheapest food that is available. It's there that, fills that energy requirement. You get calories, not necessarily nutrients from them, and people are drawn to eat them. So what is it, Stephan, about our brains that drive some people to overeat that kind of food?
Yeah, I think there are a couple different things. First of all, some foods are more appealing than others. I realize I'm saying something obvious here, but I think that's a starting point for talking about why. Why are some foods more appealing than others? Why do we want to eat some foods more than others? And a big part of the reason is that some foods cause more dopamine release in the brain. So we're kind of hardwired to prefer certain food properties. Some foods have properties that can be tasted in the mouth that are immediately desirable. So like sweetness or a fatty mouthfeel. And then also some foods cause the release of dopamine in the brain. Dopamine is a motivation and learning chemical that sets your motivational drive to consume a particular food. And so when you eat a food that has a really, nice taste in the mouth, it has the sweetness and the fatty mouthfeel and the salt, and then goes down into your digestive tract, and your digestive tract starts breaking it down and figuring out what the chemical composition of it is and communicates that back up to your brain. If your brain gets wind of this food having high levels of certain specific nutrients that stimulate dopamine release, carbohydrate, fat, protein, salt, and glutamate which is that umami flavor
delicious.
that's in it is in soy sauce and cooked meat and bone broth. So your dopamine starts to spike, and especially when those things are in combination. So if you're just eating, if you have a bowl full of granulated sugar and you're just like scooping that into your mouth, that's not very pleasant. I don't think that's going to release a lot of dopamine, probably. But take that and put it in with fat and starch and chocolate chips and bake it into a cookie. And then all of a sudden you've got something very appealing. And again, based on the properties that I described, it's not surprising why that's appealing. That has physical and chemical properties that stimulate dopamine in the brain. And so we are drawn to these calorie-dense mixtures of fat and carbohydrate and other dopamine-stimulating nutrients. So those cause us to want particular foods, and they increase our motivation to eat, to purchase those foods, and then to consume it. And then that may also be part of the reason why we overconsume them, or it may just be that gets them onto our plates and then we overconsume them for other reasons.
Yeah.
So one of the reasons that we overconsume those kinds of foods that I think is pretty well established is that they are lower satiety per calorie. So the way that our brains detect or generate that sensation of fullness that makes us want to stop a meal, calorie-dense, ultra-processed foods give us less of that per calorie. And so we have to eat more calories to get that same feeling of satisfaction that makes us want to push away from the table. And then you do that day after day after day in your meals, and weight gain is not surprising as an outcome in that scenario. Yeah, so that's a couple of things. And let me just also specify that I don't think that we have a complete picture yet of exactly why these things are fattening. So what I told you, I think, is the best picture that we have right now. It's possible that there could be other factors that we're going to learn about over time. The research is ongoing, but that's the best picture that I can paint right now.
Yeah. With that satiety piece, so if I think about the different diet camps, and you've got the low carb, keto, and then, everyone else, I'm just going to sort of think about that camp. And then you've got people who might be used to having muffins and toast and cereals. And then what they do is they go low carb, and then they swap out their muffin for like a low carb muffin, and they swap out their toast for keto toast, and they wonder why they are as hungry as what they were before, or that they haven't sort of seen a subsequent sort of improvement in body composition, which is one of the reasons why people switch their dietary approach. And I've often thought that it's because regardless of whether or not there are carbs in that food, like they're still highly palatable. They don't take a lot of sort of digestive energy. So, and actually in terms of satiety, they're just not actually that satisfying compared to vegetables, protein, other foods, which are a whole lot less processed, and we have to do that work of processing them.
So is this something that you've observed with your clients, that they switch over to keto versions and don't lose as much weight as they were expecting to?
Yeah, actually. And it's people who might just see on the internet what keto is, and then that they see the one person that managed to lose weight doing what they've just sort of described, and then they see all these, influx of keto products and think that that's the answer. Yeah.
Yeah, that makes sense to me. I mean, I guess I would expect someone who just switches to keto versions of what they normally eat, I probably would expect that to cause some fat loss if the person is carrying excess fat, just because I do think macronutrient restriction is one of the things that can modify body fatness. But I think you're right. I mean, first of all, some of these products are not as keto as they claim to be.
Yeah.
So I think that could be part of the explanation.
Yeah.
But I think you're right also that we're talking about calorie dense processed foods that are designed to be as appealing as possible. And so I think if you're just swapping out the foods you're eating for foods that are, to your sensory systems very similar, and to your digestive tract very similar, I don't think you're going to get as much effect as if you're eating, simple, less processed foods that are compatible with the keto diet. I think the keto diet can be, it can certainly be more calorie dense, because it can, typically has a higher proportion of fat, and that can be compatible with weight loss despite the higher calorie density. But there are some foods that I think most people would eat on a well-planned ketogenic diet that are lower in calorie density, like vegetables, meat, even fattier meat. Meat is mostly water. Meat is 3/4 water. So I think fattier meat obviously is more calorie dense, but meat in general is not one of the most calorie dense foods. And so if you're eating, something like a steak, it's not a particularly calorie dense food. If you then swap that out with some kind of processed food that is very calorie dense, you're probably not gonna get as much weight loss benefit as you would have from the whole food.
Yeah, I completely agree. Stephan, you mentioned dopamine as, one of the drivers of why we eat. What strategies do you see as being helpful for people who recognize themselves in that description of being unable to sort of like control the amount that they eat? Like, is there anything that we can do?
Yeah, there absolutely is. One cool thing about the dopamine reinforcement system is it's pretty well understood. And so you can design strategies around it to kind of give it a helping hand or work with it if that's one of your main problems, which for a lot of people it is. And so I think the most basic thing that I would suggest first is controlling food cues, controlling sensory cues that are associated with food. So if you live in a food environment that's constantly feeding you food cues, so let's say you're at work and there's donuts in the break room or there's pizza in the break room, and every time you walk in there, you have to look at it or smell it. You're sitting in your living room and there's a bowl of candy there that all you have to do is turn your head and it's right there and it's within reach. You have cans of soda or some other, tempting food, cookies or brownies on the counter, easily accessible. You can see it, smell it. Those are the types of food cues that get your brain stimulated. So, the dopamine system, it's very simple in a way. It's if there's nothing that reminds you of those food around, you often will not experience a craving. But as soon as there's something there that tells your brain that food is available and it's easy to get, your brain will generate a craving, a motivation for you to eat that food. If it's not there, you won't experience that craving, or it won't be as strong. And so that's the first thing, is just put it out of sight. Don't have the smells, don't have the sights around. Try not to expose yourself to food advertising too, like on TV or billboards, if it's possible for you to control that. Because that stuff, it just all feeds in to that system. Those food cues, they activate the desire to eat those foods. And that's just a really basic thing that I think we could all benefit from. To me, that's just like food environment hygiene, is minimize food cues between meals. And then another thing you can do, if you're someone who really has a lot of trouble with certain foods, which many people do, especially if they're having weight problems, they might have certain foods that they really have a hard time controlling their intake around. Not everyone who has obesity is like that, but is more common among people with obesity. And if that's the case, there may be foods that you just really shouldn't eat at all.
Yeah.
If that's a big problem for you, then you might want to completely exclude those things. Because one of the interesting things about the system that we can exploit is that it forgets over time. It forgets it forgets how to stimulate these motivations. That response kind of gets weaker over time. So if you think about someone who is a cigarette smoker, if they quit, they're going to have a really hard time the day they quit, right? Their brain, they're going to really crave a cigarette. Their brain's going to try to find ways to get them a cigarette. The next day is going to be hard. A week from then is going to be easier, but not as hard, as long as they've managed not to smoke. So you don't leave, packs of cigarette around the house. You don't go to places where people smoke. You don't expose yourself to those cues that stimulate the craving. So a week later, it's going to be easier. After a month, it's going to be starting to get pretty easy not to smoke. You're not going to have as many cravings anymore. And a year from then, you're probably going to hate the smell of cigarettes. It's probably going to be gross. You're probably going to have no desire at all.
Yeah. And you're going to be the most annoying person in the room as the converted smoker. Just kidding.
Maybe.
Yeah.
But I mean, that's how it is for food. So if you don't eat a particular food or type of food for a long time, your brain just kind of forgets that association over time, and you don't have that same reaction, that stimulating reaction when you encounter it, and that you won't experience that strong craving like you used to.
Yeah.
Yeah, so that's an additional strategy is you just don't expose yourself to particularly, I'm not saying do this for everything because it's a pretty, intense tactic, but if there are particular few foods that really get you going that you have a particularly hard time with, I think that can be a helpful strategy for people.
Totally. And people talk about foods like that all the time. They're like, chocolate is my nemesis. My one vice is potato chips, that kind of thing. And I feel like when they talk about it, to them, the drive is so strong, they cannot ever imagine never craving that food. But as you describe, if that system weakens over time, then you've actually just got to hang in there. You've got to make the decision first, and then you've got to hang in there and put that essentially it's hard work initially, but ultimately they'll sort of reach a place where they'd like to be.
Yeah, that's right. And it gets easier over time. So the hardest is right away when you first start not consuming it.
Yeah.
However, one thing I should tell you also to warn people is that the way the system works is that even though it will forget that over time, if you eat the food again, it will immediately snap back and remember. So it doesn't take doing it a bunch of times. You do it once and you can be back to where you were right away. And so even though it forgets, it's still in there somewhere and it can be reactivated.
Okay, that's super interesting. I used to be super addicted to Wrigley's or Extra chewing gum, and I couldn't go like a day without having a packet. And then one day I just quit cold turkey back in 2012. So it's been 10 years now. But in my head, I can never have another piece of gum because I know if I do, then it's all on. It's all on again. So
that could be
actually,
true.
Yeah.
And it's the same way for people who smoke cigarettes. You have it may have taken more than one cigarette to get you addicted initially, but once you've been addicted and quit, it might only take one to get you fully relapsed.
Yeah. No, that's such useful information for people to be aware of. Stephan, really briefly, if it's a possibility to do this briefly, I talk to people who say that doesn't really matter what they do. They might lose a small amount of weight and then they're just stuck at a particular level and their body seems to defend that level of fatness regardless of what they do. And they may lose a little bit more, but it seems like the drive to eat massively increases. Is this related to how to our body, sort of our personal fat threshold? Is there anything there we need to be mindful of or aware of?
So personal fat threshold refers to something else, but the concept that I like to talk about is the set point.
Yeah.
So the set point, and by the way, I'll just say briefly that there's controversy about whether we should be using that word set point, but it is a fact that the body defends body fatness. And I should say the brain really is what's responsible for this. There's a system in your brain that defends your current level of body fatness. It doesn't mean that it can never change. Obviously, most people gain weight as they age. However, it's particularly resistant to weight loss. So in people who have obesity, their set point is elevated, which means their brain is defending a higher level of body fatness. And if they try to lose weight, they will encounter a vigorous, typically, depends on the individual, but typically they will encounter a vigorous defense system that is trying to stop them from losing weight. And this is, even though it's from the brain, it's not conscious. I'm not talking about psychology. This is every bit as non-conscious as how your digestion is regulated, how your breathing is regulated. The brain does a lot of things that is completely non-conscious. It's just like, it's as mechanical as your thermostat in your home. So I don't want people to think that this is like a psychological thing. It's really not, even though the brain is doing it. And so, so there's this pushback. It makes you hungrier. It cuts back your metabolic rate, and it resists weight loss, and it tries to get fat back after you've lost it. So, that's very much the case. The experience that you described from your clients is what's happening.
And then is there any way to override that?
Yeah, so there, I don't want to say override. That's a pretty strong word, but I think there are some ways to work with this system to allow it to accept a lower weight to some degree. And, I don't want to present this as like a silver bullet for, magical, easy, permanent loss of large amounts of weight. But I think there are things we can do to make success more likely and to make weight loss maintenance more likely. And essentially it boils down to how easily can you induce and maintain a calorie deficit in a way that feels good and is sustainable in that person's life. And so some of the ways are controlling your food environment. So I talked about that. I think that's a really useful one because I think most people in a country like the United States eat more food than they realize. And some of that is just stuff that's around that they're grazing on. So low-hanging fruit, get rid of that stuff and get rid of all the food cues it's associated with that are stimulating your drive to eat. And then also coming back to the other point I made, which is to eat foods that are higher satiety per calorie. So foods that are lower in calorie density, that are higher in fiber, that are higher in protein. And actually, I want to come back to this calorie density piece. I want to make sure people understand what that is. It's the calories per gram of food. So if you have a food that has a lot of water and fiber, like oatmeal, that has a lower calorie density. If you have a food like crackers, which has a similar nutrient composition but has very little water and maybe less fiber, that has a higher calorie density. And so the oatmeal is going to be more filling per calorie because if you eat the same number of calories, if you eat 100 calories of oatmeal, it's going to fill your stomach up more than 100 calories of crackers because it's coming along with all that extra water and fiber. And so higher calorie density, higher protein, higher fiber, those things all create higher satiety per calorie. And then avoiding foods that are highly palatable. So foods that are really super delicious combinations of carbohydrate and fat, that will also help with satiety too. And so if you do those things, you can sit down to a meal and eat until you feel comfortably full, but you will have consumed fewer calories than if you had eaten foods with the opposite properties.
Mm-hmm.
And what we see is that those foods that are more sating and more satiating, those foods tend to be simple, unrefined foods, types of foods that our distant ancestors might have eaten, like whole grains, oatmeal, brown rice, wholemeal bread, and then as well as fresh meats and eggs and fruits. And then on the other side, the foods that are very low satiety are all the calorie-dense processed foods, candy bars, white bread, cookies, bakery items, fried foods. Yeah. Those are the types of foods that are very low satiety per calorie.
Mm-hmm.
And sometimes people think, well, how could they be low satiety? Because when I eat pizza, I feel really full. But the key is low satiety per calorie. Yeah. So you might feel really full, but you probably ate twice as many calories as you would have if you had eaten simpler, unrefined foods. Yeah. And so, so I think that's just 2 tips: controlling your food environment and trying to eat high satiety foods. That's just 2 tips. And I'm realizing you asked a more specific question. Sorry, I'm a little on autopilot.
No, that's fine.
You asked a specific question about the set point. But I think some of those things still apply. Yeah. Some of what I said still applies. Yeah. But what I really look for, diets that might be able to impact the set point to allow your brain to be comfortable at a lower weight, are diets where you can put people on it and they spontaneously eat fewer calories and lose weight without having to count calories. Yeah. And so when I see that someone's eating a diet, they're losing weight, they're not feeling hungrier, they're not counting their calories, that to me says that there has been a regulatory change that's happening where their brain is allowing that weight loss to occur without fighting back. So that to me implies that there has been some degree of change in the set point. So just a few things that I believe probably can do this: higher protein diets, lower carbohydrate diets, lower fat plant-based diets, and also to some extent increased physical activity, I think, can do this, and possibly getting restorative sleep and stress management.
Yeah, nice, Stephan. And I'm mindful of the time. So, but I did just want to ask you one last question about physical activity that you just mentioned. Is that how, does that sort of mediate that relationship between, like, no, it's not the right question. Does it impact on the brain in a way that allows someone to, I guess you just mentioned that it could help regulate and change that set point for people. Where do you see its importance with regards to obesity? And we know exercise, if you put it in a pill, it could probably solve everything, but obesity itself, maybe not as much.
Yeah. It's kind of a complicated topic, and I'm not going to get deep into the weeds, but high level, it's not very good for weight loss in people who currently have obesity. It does cause some weight loss, and I think kind of recent media narratives have they really want to be like, exercise doesn't do anything for body weight. I think that's going a little too far when you look at the evidence, but I do think that it is less impactful than diet for weight loss. I think diet is a more powerful lever than physical activity for weight loss. But the complexity comes in when you look at the data on weight loss maintenance, where actually exercise seems particularly important for maintenance of lost weight. So once you've lost the weight, ideally mostly by diet, but exercise can be a good adjunct to that too. But once you lose the weight, exercising regularly really seems to help people keep it off. It seems to make a big difference. And then the other thing is, it seems to help with prevention of weight gain.
Yeah.
So people who exercise more tend to gain less weight over time.
Yeah.
And I don't want to say the evidence is ironclad there. I think there's more research to be done, but there are several lines of evidence suggesting that. And what you see in animal models and also the human evidence to some degree is basically when you are very sedentary, people who are very sedentary, they get appetite dysregulation.
Yeah.
And so that's how it seems to happen mostly, is that people who are very sedentary, they actually eat more than someone who is even just lightly or moderately active.
Mm-hmm.
So there's something about, even though they don't need to eat more, they don't need those extra calories, there's something about that, being very sedentary that just stimulates appetite.
Yeah.
And I don't think we really understand how that works. It's just kind of something that's been observed in animal models and to some degree in human studies. So yeah, that's kind of an overview. And there have been some genetic studies that support that as well, that physical activity plays a role in whether or not people develop obesity.
Yeah, so interesting. And now, I look at exercise as with regards to weight loss, as it's a good habit to get into that allows you to feel good. Therefore, you're likely, when someone's feeling good, it's easier to make better food decisions as well, rather than it's the exercise that's burning that extra 300 calories that's, causing that is the main factor. But of course, it all contributes.
Yeah, and I mean, also having a strong, capable body is really important in life, I think.
Yeah.
It, like, especially as we age, people, you'll see as people age that the way that they age based on whether they are exercising or not can be very different. And people who don't keep their bodies strong tend to not age very well. And so, yeah, and that has many implications for how we spend our latter years. So I think exercise is hugely important from a health standpoint, to some extent from a body fat standpoint, and from a quality of life standpoint.
Certainly, I completely agree, Stephan. So I am mindful that we've been on for over an hour, so I'd just like to thank you so much for your time this afternoon. I really enjoyed our conversation. I've got so many questions that I haven't asked because you're such a wealth of information. But the great thing is you're also very good at sharing that information. Can you just let people know where they find you on social media, but also your website?
Yeah, I'm most active on Twitter, which is at @Guyenet, Guyenet. And I also have a website, stephanguyenet.com. Not very active on there currently, but there are a number of articles that I've written over the years. And then other than that, I just appear on podcasts and occasionally write articles here and there.
Yeah, that's awesome, Stephan. And actually, is there any update planned for your book?
No, I don't have any planned.
Yeah, okay, that's good. It's, still very relevant, really interesting, and highly recommended. And we'll pop links to all of those contact details in the show notes. Thank you, Stephan.
Thank you, Mikki.
All right, guys, well, you may need to listen to that again and take notes because he is such a wealth of information. And as I said, you can find him over on those platforms with which he contributes, such as Red Pen Reviews and also his own website, but also, of course, over on Twitter for sort of a daily update on what's on Stephan's mind. Next week on the podcast, I bring to you the conversation that I had with Sarah Campbell, all about the impact of exercise on the gut and vice versa. Great conversation that we had there. And until then, you can catch me over on Facebook at Mikki Williden Nutrition, Twitter and Instagram at Mikki Williden, or over on my website, mikkywilliden.com, where in addition to the recipe portal access, you can sign up to one of my monthly meal plans, be it fat loss, real food, nutrition, eating, the keto longevity plan, or book a one-on-one consultation with me. Until next week, team, have a great week. See you later.